Hi, welcome to BC Video 9.3a Part 2, the Harmonic Series and the pSeries. All right, pSeries and Harmonic Series. Harmonic Series is just a pSeries where p equals 1. Here's the definition of the Harmonic Series. It is purely this very simple series of 1 over n, summation n goes from 1 to infinity. Of course, it can't start at 0. So it's 1 plus a half plus a third plus a quarter. And that series is simply known to be divergent. We talked about it already. These denominators aren't getting small enough, fast enough for it to converge. So all you have to do is state that this is the harmonic series, therefore it diverges. Okay? But always state them by name. Now a p-series is, instead of 1 over n, it's 1 over n to the power of p. So, for example, 1 over n cubed, 1 over the fourth root of n, which is 1 over n to the 1/4. Okay? So, you have to state the value p, just like with geometric, where you have to tell me what the value of the common ratio is. So here you have to establish whether that p, that exponent, is positive or negative. Greater than 1 or less than or equal to 1. P, by the way, is always going to be positive, okay? Because if it was negative and it was in the denominator, it would just be in the numerator with a positive exponent, and it would diverge all the time. So, if that exponent p is bigger than 1, the series converges. If it's less than or equal to 1, it diverges. Now, a lot of people mess this up. They think of less than as converge, greater than as diverge. But you got to keep in mind that the p is the exponent in the denominator. So, since the numerator is 1, obviously the bigger and bigger the denominator gets, the smaller and smaller the value of the fraction gets. So if p is large, then this denominator is going to get big really fast, which means that the 1 over that is going to get small really fast, and that means the series will converge. On the other hand, if p is less than or equal to 1, the series will diverge. Note that when p equals 1, we are talking about the harmonic series, which diverges. So here what happens is the denominators aren't getting large enough, fast enough to force the fraction to get small enough, fast enough, and therefore the series will diverge. Okay, so here's an example of what it would look like. Okay, so here's writing out the first few terms. Here they are as radicals, here they are as decimals. The point is, it is a p-series. The p is equal to 1/4, and since that p is less than or equal to 1, the series diverges. Okay. So here's another one. Does this series converge or diverge? It's a p-series. Your p is 2/3. Since p is less than or equal to 1, the series diverges. A harmonic, you can simply say that. Here's another example, 1 over n to the pi. Again, p-series. P is equal to pi this time, which is 3.14, more or less. Since p is bigger than 1, the series converges. Notice we are never asked what it converges to. Okay? This is the exact same thing, except for here. Now, this is not in the textbook, which it should make sense to you, that if you have these two series and they either both converge or both diverge, the point is this. If you have, you have a series AN, and if you take that series and multiply it by a constant, well, if the series AN converged, so will this new series converge. And if the original series diverged, just because you multiply it by 3, it's not going to change the fact that it's a divergent series. So K, a constant times a convergent series, gives another convergent series. A constant times a divergent series gives a divergent. So, for example, if you have the series 8 over n, you can pull the 8 on the outside, and now it's 8 series 1 over n. This is the harmonic, which is divergent. The 8 is on the outside. 8 times a divergent is